Let's take a look at E. In E, we've got log base 5 of 8 minus 3x equals 3. So in this one, what we'll do is we'll start off by getting rid of the log base 5 by doing an exponential base 5 to both sides. Again, that means whatever's on the sides of your equation become exponents. So what this does on the left-hand side is the log base 5 and 5 cancel out, leaving you with the 8 minus 3x. And by using a base of 5 on the right-hand side, and your right-hand side becomes the exponent, be careful. It means that right-hand side here is 5 to the third power. Not 5 times 3, 5 to the third power. Which, if we do that, is 5 times 5 times 5, which is 125, is what that 5 cubed becomes. And then we can solve it like we would a normal equation by starting off by subtracting 8 from both sides, which would give me a negative 3x equals 117. Continuing right along, I can divide both sides by a negative 3. And that would give me that x equals, let's see, whatever 117 divided by 3 is. And that gives me x equals negative 39. Now be careful. I know that some of you might be thinking about being worried about plugging in a negative, and you should be worried. The only thing that we can't plug into a log is something that stays negative. So if we plug in the negative 39, it's actually not a problem, because if we go back and plug it in, notice the first thing that happens to it is that negative 39 will get multiplied by a negative 3, which will turn it back into a positive. So as long as that negative doesn't actually stay negative inside the log, it's an okay answer. But if that was something that you were thinking about, you should be. We need to make sure that whenever we plug in our answers to our log, that they don't stay negative. If they do, they're not a valid answer. They're false solutions. We've seen this before when we got answers that made our denominators equal to zero in previous chapters. So with logs, we do need to make sure that our answers make sense and that they don't make the inside of the log equal to 0. Let's take a look at one last problem, F. In F, we have log base 5 of x plus 2 plus log base 5 of x minus 2 equals 1. Well, the first thing that we'd like to talk about is I can't get rid of the two log base 5s because of the plus in the middle. That's a problem. So the problem is, can I bring these two log base 5s together? And you can. Remember, if you have a plus in between two logs with the same base, you can just bring them together as one big log base 5. And when you bring them together, what you do with what was inside is, if you remember right, you take whatever was inside and you multiply those two. So we would take the x plus 2 and the x minus 2, and we would be multiplying when we move everything inside of one log. So we'd take the x plus 2 and the x minus 2, and we'd bring them inside and we'd multiply. And again, just like before, this whole thing equals 1. So, how do you multiply the x plus 2 and the x minus 2? Well, we haven't done this in a while, but it is something we used to do all the time. It's called FOIL. So to multiply out that x plus 2 and x minus 2, we will do FOIL. Well, let's FOIL it out and see what we get. We get an x squared. Let's see, minus 2x. Plus 2x minus 4. And again, this whole thing equals 1. Well, the plus 2 and the minus 2 will cancel out. which means actually what we have is log base 5 of x squared minus 4. Now that we are down to only one log base 5, though, we can get rid of it by doing the inverse. What was the inverse of log base 5? Was an exponential base 5, so we'll do that to both sides. That means whatever was already on that side becomes an exponent. So the log base 5 and base 5 will cancel out, leaving you with whatever was inside, which in this one was an x squared minus 4. The other side, though, is a 5, be careful, raised to the first power. So that 5 to the first power is just a 5. Now we can solve that like we would a normal equation by adding 4 to both sides, which will give us that x squared equals 9. Now, how do we get rid of something that's squared? Remember, we take the square root of both sides of the equation without forgetting to put a plus or minus symbol on when we do take the square root of both sides of an equation. That will get rid of my squared with the square root, leaving me with the x that was underneath. And that leaves me with plus or minus, well, the square root of 9 is 3. So it gets me 2 answers. That gets me x equals positive 3 and x equals negative 3. Now, one of these answers works, one of them does not. Be careful, it won't always be that the one that's negative won't work. You have to check to see which one. We only want an answer that we can plug into the log that will not stay negative. So if you go back to the beginning, remember we're checking things by plugging them in for x. If we plug in the positive 3, the first log will turn into a 5, the second log will turn into a 1. That gives us a positive in both logs. So that answer of x equals 3 is absolutely fine. We end up with a positive inside both logs. However, if I plug in the negative 3 for the x's in the first log right off the bat, plugging in a negative 3 gets me a negative 3 plus 2, which is negative 1. I can't plug negatives into logs. And right off the bat, I don't even need to move on to the second log. I know that this answer is not actually a valid answer. So if they were to ask me for my final answer, I'd say that my solution is x equals 3, or remember, if I want to write it out with a little bit fancier notation, I would write it out in solution set and just put the number 3.